Hello everybody, we're moving on to problem number 3 on the 2018 final. And let's see, we're told that we have a firm that produces using this Cobb-Douglas production function and asks us to solve the problem of the firm. So essentially we want to find the wage. We'll find the wage and the interest rate because that'll solve the problem of the firm. But what we're really curious about is the wage so that we can complete the problem of the individual, because we still have it in terms of this W here. So when you need a wage, you got to go to get a job. And the first thing I like to do in this case, let's copy down the production function. F of K and L is going to be equal to A K alpha L1 minus alpha. The first thing I like to do is convert the production function into per capita terms. So what we want to find is F of K. And we know that this is a homogeneous degree 1 function because it is Cobb-Douglas. So actually, this expression will be true, that 1 over L times F is going to be equal to F of K. And similarly, that F of KL is going to be equal to L times F of K. So let's do it. 1 over L, F of KL is just going to be A K alpha, and that's going to be equal to L times F of K. We need to bring that L along with us. So remember in the Solow model, we would have an equation we could directly divide by L. There would be like a big Y in the equation. You can write Y over L, and then that would equal little y, and then you can just plug this equation right in. We won't necessarily have that. We might just have an equation where we'll need to replace this directly. We can't divide the whole thing by L. And so in that case, we'll bring a little L along with us for the ride. Okay, so what we want to do next is think about the wage that the company will pay. And in a perfectly competitive market, which we're going to assume that the wage is going to be equal to the marginal product of labor, which is going to be the partial derivative of output with respect to labor, which is going to be equal to ddL of L F of K. And we know that L F of K is equal to A small k alpha. And let's keep in our back of our heads that K is equal to K over L, because there's going to be some product rule and chain rule. And in fact, we have to use product rule right away because we have an L here and we have an L here inside this K. So let's do lefty right, righty left. So the derivative of L is just L. We get AK alpha plus the L will come along, AK alpha, K alpha minus 1. And K itself is a function of L. So we need to do the chain rule. So we're going to times K over minus L squared. So this L is going to cancel with that L, and then we'll have K over L, which is just script K. So this is, in the end, going to equal AK alpha minus A alpha K alpha minus 1. And obviously these go together. So we're going to get AK alpha minus A alpha K alpha. And then we can factor out AK from both. So we will get 1 minus alpha AK alpha as our final answer for the wage. Now for the interest rate, we can do something similar. It's just going to be the production function taken with the derivative with respect to capital. So we're going to go ddk of L f of k, and that's going to be equal to, this time we just have the 1. We have L times AK alpha. So the derivative of that with respect to K is just going to be L A alpha K, alpha minus 1, and then this is itself K over L. So the derivative of that will just be 1 over L, the K will go away, and then these will cancel. So in fact, our RT is going to be equal to just A K alpha minus 1. And that solves the problem of the firm. So in the next video, we'll put these two together with our consumption function and our savings function that we found up here and here, and then we'll be able to put everything into equilibrium.